So you've never built a kit before. Well, that's all right. I'm going to show you step by step how to do it, and this is a great one to start with. Hey, what's happening, guys? Today I'm going to show you step by step for the absolute beginner how to build an electronic soldering kit. And the kit we're going to build today is kit number 9050 from Cyber City Circuits, the red and blue strobe kit, which looks kind of like this, and it uses a couple of 555 timers, my absolute favorite IC. So to get started, you only need a couple of tools. You need a soldering iron. You're going to need some cutters. I like these flush cutting cutters. Some tweezers. If you don't have tweezers, needle nose pliers will work fine. You're going to need some solder. I like 60-40 solder. Yes, it has lead in it, but that's just the way it is. Don't use plumbing solder. This solder has flux in the center of it, and you need that to get a good flow. Now, I've also got some other things here. I've got some paste flux and some tip tinner, because one of the most important things with soldering is to keep your tip clean as possible. You want your tip to be nice and shiny like that. And you never want it not to have solder on it, so you just want to add a little bit of solder to tin the tip. Keep it nice and clean. If you don't have one of these brass sponge things, wet sponge on your soldering iron holder will do just fine. I prefer a variable temperature soldering iron. I'm using the KS GR, which is a T12 type soldering iron, and I keep mine set at 350 degrees Celsius. Now, the fumes can be a little bit bad for you, so some sort of solder fume extractor or a fan, or wear a face covering, you know, any of those things. So I want to start off by making sure that my soldering iron is nice and clean. What I like to do is just use some of this paste flux, put my tip in there, get it bubbling, then clean it off and retin it. Do that a couple times. Make sure that tip is nice and shiny so that the solder sticks to it. If the solder doesn't stick to your tip, then your tip is too dirty and you need to keep on cleaning it. Alright, that's all there is to that. Next, we're going to open up the kit and get out the components. Once you have your components emptied out of the kit, you just kind of want to separate them into like groups. This is called knolling, and that's K-N-O-L. This just makes it easier later on when you're looking for something, if they are all grouped together somewhat into like groups. Now here's our circuit board, and you can see we have some resistors. 470 ohm, 470 ohm, 68K, 68K, and we have 4 resistors there. Now, Cyber City Circuits has included in their kit here, at least they used to. Hang on a second. Well, it didn't come in this one, but they usually include a little code chart for reading your resistors. So here is a resistor that appears to be blue orange, and then we have this one here, which starts out with yellow, violet. So these are our 470 ohms. These are our 68K. If you're unsure about it, get a multimeter and test them. You don't want to put the wrong resistors in the wrong holes. Now, on to building. You generally want to start out with the components that are going to be closest to the board first. And that's generally the resistors. So I'm just going to pull off these little bits of cardboard. Some folks prefer to cut them off. I don't really think it matters. And then I'm going to do what's called forming them. I'm just going to bend them down at a 90-degree angle. Resistors are not polarized. That means it doesn't matter which direction you put them into the circuit. Some components, including ones in this kit, like the electrolytic capacitors and the diodes, are polarized and have to go in a certain way. With resistors, it doesn't matter. However, to keep things neat, you generally want to keep them facing in the same direction. So I started with this one with the yellow facing up, and I'm going to do this one with the yellow facing up as well. And then what you can do is, while you're holding them in with your thumb, is bend the leads out so that they stay in place. Okay? Now we're going to zoom down here. So when you're soldering, you don't ever want to put a big glob of solder on your soldering iron like this and then try and bring that over to the component. That's not going to work. It's going to make for a bad joint. What you want to do is start with a nice, clean, shiny tip. Make sure it's tinned. Add just a little tap of solder like that to make sure there's some solder on the tip. And then you want to place the tip so that both the tip is contacting both the pad and the leg of the component. And then you want to bring in your solder like that. Then take the solder away and then take the iron away. Watch, I'm going to do it again. Tip touches the pad and the leg. Bring in the solder. Take the solder away. Then take the iron away. And what you should end up with is a solder joint that looks like a little mountain. And it should be nice and shiny. If it looks like an apple, that's not a good joint. So I'll do it again for here. Iron, then the solder goes away and the iron goes away. Again. Once that's done, pull your legs back straight up and bring in your flush cutters and cut them nice and close. Watch out where the leads go. They tend to fly everywhere. You don't want to step on one later. They are worse than Legos. And you should end up with something that looks kind of like that. Alright, I'm going to do the other two resistors. You don't have to watch that. Okay, so I've got all my resistors in, and you can see they're nice and flat to the board. Our next lowest component are probably going to be the sockets for the 555 timer. Now you notice there's a notch printed on the board. There's a notch in the socket, and that corresponds to the notch in the IC itself. So make sure you line up all your notches. That helps you keep things in place nice and neat. Now what I like to do to hold these in place while I'm soldering is just use a piece of cellophane tape. Telephone, oh my. That'll help you keep things in the board so that they stay. Then what I like to do is solder in one leg, and make sure it is nice and flat on the board how I want it. The reason you only want to do one leg is because you can still reheat this leg and move it around to get it where you want it. If you do more than one leg, well, then you're going to have problems. I'm just going to solder these in. Now, when you're doing stuff that has multiple pins, you want to make sure that you don't have the solder going from pin to pin. That's called a solder bridge, and it will short different pins together, and things will not work out how you wanted them to. Now, you're going to notice a shiny liquid type coating that's left over on this black mat. That is the flux that is in the center of that solder, and it's corrosive. It does need to be cleaned off. We're going to clean it off later. You want to get your soldering done first. Alright, I'm going to do the other socket. So we've got our resistors in and our sockets are in. Everything is nice and flush to the board. We don't have any solder bridges, so we're good to go. Now we can make a decision. Do we want to do our LEDs or our capacitors? I'm going to do the capacitors next. So first we have this 2.2 microfarad electrolytic capacitor, and it is polarized. If you look at this white stripe here, that is the negative side. So if you look here on this capacitor pad, you see there's a plus sign, so make sure your white stripe is not on the plus sign side. Get that down in there on the board. Bend out the leads. And again, we want to solder one leg. Make sure it's sitting nice and flat and level. Then we'll solder the other leg. Still looking good. Then we'll cut off our excess legs. That leaves one more capacitor. This one is a ceramic capacitor, a multi-layer ceramic capacitor. You can see it right here. It is not polarized, so it can go in any way. Now you can see that one doesn't quite fit. They've used too small of a footprint on that. But don't worry, it'll still work. We're just going to spread those legs apart. Clean the soldering iron off. And do the same thing we've been doing. One leg. Check it. Adjust it if you have to, and then solder the other leg. Then we'll take off the excess. So that leaves us with the LEDs. Again, LEDs are polarized. Usually, I say usually because it's not always the case, usually the long leg is the positive, which is called the anode, and the short leg is the cathode. And I don't know how well you can see this, but there's generally a flat. Let's see if we can zoom in here. See the flat spot? That lines up with the short leg. That is the negative side, or the cathode. Also, on your board footprints, the square is usually the ground. So we'll put that in there, bend our legs out, and solder it just how we've been doing with everything else. One leg at a time. Check to make sure it's sitting how we want, and do the other leg. Then we'll cut off the excess. Alright, I'm going to do the rest of the legs, or the LEDs. Alright, all our LEDs are soldered in. So all that leaves us with is the battery connector. Red for positive, black for negative. You want to make sure that you get those in the right holes. Now there's not enough wire to bend through there. So again, a piece of tape will be a good friend to you here. Something to hold them down and hold them in while you're getting that initial solder on there. Okay, so that is it for our soldering. Now we want to inspect. Again, we're looking to make sure there are no solder bridges. Nothing touching. Okay, everything's looking good. Make sure you get your cutoffs out of the way. You don't want them sticking to anything and shorting it out. So now we're down to our ICs. And you can see the legs are a little bit splayed out. What you can do is just kind of sit them on your table and just give each side a little pressure until they look like they're each at about 90 degrees. And then you can insert them into the sockets, making sure you line up the notches and that they all fit easily, and that none of the pins end up bending and ending up outside of the socket. So take your time with this part. Form these legs the best you can so that they're nice and straight. When you put them in the socket, just make sure that you shouldn't have to force anything. I mean, it's going to take a little pressure to push them in, but you shouldn't use excessive pressure. Now, everything looks good. So let's clean up that flux on the back of the board. Okay, the best way to clean it up is with an old toothbrush and some rubbing alcohol. I'm just going to pour a little bit into this cap. And you notice my soldering iron is no longer in the area because the alcohol is, of course, flammable. And we don't want any fires. Give a good scrub over all the pins that you just soldered. Get that excess flux off of there. Then I'm just going to blot it with a paper towel. Looks good. So then we can plug it in and see if it works. If it doesn't work the first time you plug it in, don't fret. You can always fix whatever you've done. You ready? Here we go. Now, if you look here, I've got two blue LEDs that aren't working. Well, three blue LEDs that aren't working. Which is interesting, because I've put them all in the correct way. So, what I'm going to do is get the alcohol out of here. bring my soldering iron back. And I'm going to unsolder one of the LEDs. I have this little desoldering pump here that works real nice. If you don't have one of these, you can try and just heat them up and wiggle them out. So I'm going to start with this one here. Going to heat it up. These pumps are like, you know, less than 10 bucks. Great thing to have. Just suck that solder right off of there. And we should be able to wiggle that guy out. Like a loose tooth. Alright, this one here still has just a little bit of solder. So I'm going to heat it up. Careful you don't burn yourself if you're doing this. Sometimes you can give it a shake. Not in this case though, huh? Alright. Let's get in there and get her hot. There we go. And out it comes. So I'm going to test the LED using a multimeter, because chances are we just have bad LEDs. What you want to do is put your multimeter on the diode mode. Since I cut those leads off, this is going to be a little difficult. No, the LED's working. Huh. Alright, let me see if I have some more. Okay, here's another LED. You can see it works. So the other thing I want to make sure is that this is set up right. What I'm going to do is I'm going to put my meter in continuity mode, which is the beep mode. And I'm going to test this cathode, find out if it goes to ground. Doesn't. Does it go to negative, positive? No. Which pin is this going to? Okay, that's going to the output pin there. That's pin number 3. That's the output pin. Just want to test here. So what I'm going to check now is I'm going to check the negative lead on one of these other blue LEDs and see if it is also going to pin 3. It's not. So I'm going to put this one in backwards. We'll see what that does. Cut these leads off. We'll hook it back up. Yep, that one's in backwards. So I bet you those two are in backwards as well. Maybe not, because that's going differently. Huh. Now, the 555 can both sink and source current, which means it could be hooked up backwards or forwards. Let me check these last couple of LEDs here. We'll put this back in diode mode. Alright, I'm going to replace them and just see what happens. Well, I put new LEDs in. I tried them in both positions, and I can't get anything out of it either way. So I'm not quite sure what's going on there. But it's a nice kit otherwise. I want to thank the fine folks from Cyber City Circuits for sending that out to us. Check them out for all your kit needs. They've got tons of these little kits on a monthly thing you can subscribe, or you can just buy them outright. They also do PCB design and manufacturing. Check them out. I promise you, they make really nice stuff, and it's really affordable. So I hope you like this video, even with my little foibles there. If you, whoops, come on. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to you. Big thanks to Cyber City Circuits. That's it. I'm out. Peace.